Hi, I just was to be about to do a repair here on a ham radio, and well, I found my counter doing nothing anymore. So there is a signal put into input A, but you see counter does not count. So something really wrong with my counter, and yeah, that is really a worse situation if your testing gear is not working. That's really not very nice. Well, nothing. So let's check input C, and yeah, so it's 15 megahertz, which is coming from my generator. So normally input C is for 40 megahertz and above, but this C input is also able to take a signal with a low frequency, and yeah, that is telling me that at least the processor and all the digital components seems to work. So yeah, maybe it is really something with the pre-amplifier or the amplifier in the signal path, that we have no reading anymore. So that means before I can go ahead with my radio repairs, I have to check what's going on here with my counter. Okay, so unit is open, as you can see, and just taken off the housing, and I directly recognize a strange smell. So something has burned for sure. So let me take off the GIB interface, which is this PCB, and then yeah, let's see where this burning smell is coming from. Wow, that's really strange, really strange. So here we have our counter mainboard, and well, from this side it looks fine. I mean, this cup here looks a little bit odd, but I don't think that it is a cup itself. So it seems that it is only this plastic here over the cap. I know that there are some troubles with these cups down here, so I definitely gonna check these cups. But yeah, there is still the burning smell, but on this side, so maybe something is here under the OCXO, so that might be. But here on this side I can't see anything. So when I flip it over, there is, yeah, that seems to be a burning mark. So when we zoom in here, so something is wrong here. So that looks like that could be the burning mark, and of course it is smelling a little bit strange. So maybe that this is our problem. I do not know why. So what we definitely need to check right now is what's about our our power supply voltages. So that will be next to understand what's going on. So maybe that there is a voltage which is pulled down, so due to excessive power drawn component, which might be shorted out. So that is one idea. Anyways, let's go and check our voltages. Okay, so first of all, let's check some voltages, and we have down here our power transistors, which are Q8, Q12 and Q6. And well, we should have at the collector at Q8, which is here, 5 volt. And yeah, 5 volt, that is close enough. And you can see up here our AC portion of this voltage, and so that represents a ripple, and it is 15 millivolts, so that looks quite good. So we check our next one, which is 5 volt as well, and that is good as well, with 19 millivolt AC portion, so that is fine with me. And the next one is a Q6, and Q6 should show minus 5 volt, and it is showing 5.2 approximately. So the delta which is allowed is plus minus 0.2, so we are in the specification, and the AC portion is 13 millivolt, which is fine. So that means these power rails are obviously fine, so we have to go ahead. Okay, and down here we have our both voltage regulators, and yeah, so these regulators are under our OCXO, which is lying here outside, but it is still connected. And we should have our positive and negative rail here. So this here should be our minus 11 point, let me double check, IC4, right? So that should be minus 11.2, and we have 11.3 with 21 with 20 millivolt AC component, which is fine. And our positive rail should be 11.2, and it is 11.15, so that is fine as well. 13 millivolt AC component within this voltage, and that is fine as well. So that means our voltages are all available. So something must have happened to this little resistor we have seen when we flipped it over. So now we need to find out where exactly this little resistor is connected to, and we need to check if it is still okay, this resistor, or maybe it is really burned off. So that is now our next step. Okay, so what I can say so far is that our little resistor down here is in the minus 11 volt power supply line, and Well, what I want to see right now is if the voltage is available, and of course our minus 11 volt is there. That is what we have checked before. But then on the other side of our resistor we see there is absolutely nothing, and this little resistor, this chip resistor down here, is only a 10 ohm resistor. So and that is what we already guessed before, that this resistor is burnt. So that is what has happened. That means we definitely have a short which was pulling down this 11 volt, this minus 11 volt trace, and was finally burning this little resistor. So that means we have now to check where this little, yeah, not little, that is a big short, and we need to find the short. Okay, so let us check right now if we can see the short. So the meter is adjusted to the beeper, and the counter is disconnected from mains. So I'm now simply interested, you know, if we have really a short, and therefore I put my probe down here, and let's see. Yeah, so we have definitely a short, and if we watch the schematic, so down here, this is our R146, which is 10 ohm, and we see here our minus 11 volt rail, and this resistor is burnt. So what we see here, so this is ground, of course, and yeah, if we probe between this point of our resistor and ground, we have our beep, which means there is a short. If we are now really lucky, it is only maybe this capacitor, so this is electrolytic capacitor, which might be faulty and has produced a short over the time, or maybe, if we are lucky, one of these both capacitors here. So the first of course is this C111. It is not the best copy, but anyways, so this here is the first component which is really suspect, and therefore let us check this component first, because if it is not one of these three capacitors, then we are really here in the complete circuit, and maybe that we have then a dead transistor, or I don't know. So I still hope that the resistors here around our transistor, and of course around here this Zener diode, that this is still okay, so that we really have only a shorted capacitor. So that would be the easiest to fix. Yeah, let's see. I gonna take out this capacitor, and let's check what we can find. Okay, I've not taken out the electrolytic capacitor first, so I've taken out our little 10 nanofarad capacitor, which is, where can you see it? It is there. Okay, so I am now interested if we still have our short. So you see beeper is still on, and let me go back here to one side of the broken resistor, and let me go back to ground, and let me double check. Yeah, I'm definitely on the right position here, and wow, that is clear. But this is ground. This is a ground pin, and this is the opposite side, so the second side of our 10 nanofarad capacitor, which I have taken out, and you see and you hear, right, there is no short any longer. And when I now go, I've put it here. This is my double-sided tape, and there is our little capacitor sitting. Hey, so this guy is shorted out. So normally we have always our electrolytic capacitors which are having this problem. This capacitor is showing a resistor of 22 ohm, so that it's really toasted. So let me double check it. If we can read a capacitance. If I go down here with my tweezer, and that is funny. So when we double check it here, so it is on automatic measuring mode, and we let the meter identify the component, and it should be, of course, a capacitor, but what you can find, the meter is reporting a resistor. So it is not an capacitor any longer, and 22 ohm. So that is what has caused, the short. And wow, so that is the reason why, of course, our resistor, come on, this little 10 ohm resistor is toasted. So that is clear that we have this effect. Okay, so let me replace the 10 nanofarad capacitor. Let me replace the 10 ohm resistor down here, and let's hope that then the counter is fixed. But that is seldom that one of these capacitors is failing. So we all know that the electrolytic capacitors are much more often to fail. But anyways, if that is the reason for failing, wow, that would be great. And maybe that the counter afterwards is working again. So let's double check what we do, and let's replace what we have to replace, and let's see. Yeah, so the situation here on the board in macro mode. Now let's see if we are able to get off the resistor. Oh, you have to do it all through the camera. So let's go down, and here is our resistor, and I put it here down on my tape. And now I have to clean it, and then we replace our new capacitors. I have already here my 10 nanofarad capacitors, very nice. So we can do it. Okay, so let us check the little resistor which I have taken out just right now. What we can find with this little resistor, and look at this, it is not completely toasted, it is 55 ohm. It should be 10 ohm, and together with the capacitor which we had checked with, I go to the capacitor once again, and the capacitor is 22 ohms, so that means we have approximately, I don't know, 80 ohm, a little bit less. So that means maybe this 80 ohms have saved our circuit a little bit, because yeah, so the power or the current was limited by these two these two resistors in series to ground. So maybe that this has protected the circuit, I hope. But yeah, it is funny that yeah, the resistor is not completely dead. So okay, very nice. So let us replace both, and then we know a bit more. So by the way, this here is a new acquisition. It's a nice LCR meter, and yeah, I will show it in another video what we need these LCR meters for, and why these meters are so important, but that will be another story. Just yeah, if you wonder why you haven't seen this meter before. So it's a new acquisition. Okay, so let's go with our counter repair. Wow, I've almost killed my pets, so they are really loose. You can see it here. So the impact was already very heavy, so you really can see the burning marks here on the PCB. So maybe that the problem was already available for a longer time, so that the power consumption was much too high due to this leaking capacitor. And yeah, you can really see the burning marks, and that is the reason why, you know, these pads are so loose. So now I have to be very careful. So maybe I put maybe a little wire from here to there, just to make it a little bit stronger. Yeah, let's see what we can do. Okay, so the new components are in. Well, not too bad finally. Well, I have put a drop of glue down here to this pad, and it seems to be stable enough. So yeah, I guess we can leave it as it is. And well, so let's check if the function is back. Okay, so the counter is connected to mains, so let's see what's happened when we switch it on. Oh, no error report, so that is promising. Now here we have our generator, and it sits on 15 megahertz. So yeah, let's see. Input A. Whoa. Hey, it's back. Great. Okay, so the oven is cold, so it is clear that frequency can't be just right. So that will take approximately half an hour, whatever. But anyways, it is back working. Is that great? So love it. Okay, and all is back in. So here our front end is closed, and the oven oscillator is back in. I've checked the capacitors, and the ESR is still good, so no need to change these capacitors. And I have of course checked the ESR of this capacitor here, which I suspected first as well, and it is just fine, so no problem whatsoever. Okay, so now I will put it back to the shelf, and then let's do our final check. Okay. Okay, so let's final check the unit. It is back at its place, and yeah, self-test is running. Very good, no problem. Okay, so my generator is set to 15 megahertz, and that is what we should read. If we connect now our BNC coax cable to input A, which is here. Okay, so, and now I need to switch on the generator, and have a look. It is working just fine. Now it is connected to my external standard, which is my lab standard, a very high precision one, and you see it is working just fine. So quite happy right now. So my test gear is back to life, and that is of course essential. Okay, so that was a not planned repair, and it was as well a not planned video, so I hope you enjoyed it a little bit, and yeah, if you like it, just give me a big thumb up for this video, and catch you next time with a more normal repair or tutorial or whatever. Okay, bye, see you.